Welcome to the deep dive. Today we're getting into some really tight spaces, the kind that are often just ignored in data infrastructure.
Exactly. We're talking about specialized environmental monitoring.
Specifically, how do those high-value server cabinets, the super hot enclosed racks, protect themselves? And not just from a fire, but from that first dangerous spike in heat.
And that's our mission today. We're going to unpack one single, highly specialized piece of hardware. Think of it as a shortcut to understanding this whole world of industrial-grade preventative tech.
Okay, so what is it?
It's the NTI E-SDS-TAA-PV2 smoke detector. But, and this is key, it has a built-in fixed-temperature heat sensor.
A heat sensor set to what?
It's set to 135 degrees Fahrenheit or 57 Celsius, and it's also TAA-compliant.
TAA-compliant, so it's cleared for government use.
Exactly.
Okay, let's unpack the dual job it's doing. It's designed to connect back to these centralized NTI EnviroMUX systems, right?
Systems like the E16D. The whole idea is to get an immediate alert to an admin when something goes wrong inside that one specific cabinet.
So it's not just a general fire alarm for the room, it's for the cabinet itself.
Precisely.
It's got a photoelectric smoke detector, which makes sense. But, 135 degrees Fahrenheit. That sounds incredibly low for a fire alarm, doesn't it?
It is low, and that's
Yeah.
actually the brilliant part of the design. See, we're not waiting for a flame.
You're waiting for something else.
We're waiting for the electronic failure threshold. What's so fascinating is that 135 Fahrenheit is the exact temperature where critical components like, capacitor insulation or some plastic materials start to degrade really rapidly.
So if the air inside that box hits 135, you've got thermal runaway.
You've got it, even if there's no visible smoke at all. This device is designed to catch catastrophic component failure before ignition ever happens.
Okay, that makes sense. So once that early warning signal is triggered, how does it get the message out across, say, a huge facility? That brings us to connectivity.
Yeah, and this thing is built for scale. It integrates using really simple screw terminals.
So no complex wiring.
None. It just connects right into the monitoring system's digital ports. And critically, you use standard CT5, 5E, or 6 cabling.
The stuff everyone already has running through their walls.
The very same. And the reason that matters, beyond just convenience, is distance.
Right. How far can you run that cable?
You can run that connection up to 1,000 feet.
1,000 feet.
Over 300 meters.
Yeah.
So, think about that. You can monitor cabinets across an enormous warehouse or even multiple remote closets, all from one central hub.
And to do that, I assume the sensor itself can't be drawing a lot of power.
It barely sips it. It runs on a low-voltage supply and draws something like 50 microamps in standby. It's almost nothing.
Which means you can deploy hundreds of these things in remote cabinets without needing to worry about adding a bunch of new power infrastructure just for the sensors.
That's it. That low power draw translates directly into massive deployment flexibility.
And we should just touch on that TAA compliance again. It basically means if you're a government contractor or you're working on a military site, this device is already on the approved list, no questions asked.
So if you put it all together, what you have is the epitome of preventative centralized monitoring.
Right. It's this combination of smoke detection for one kind of threat.
And that critical, scientifically chosen 135-degree heat threshold for another. It's all about ensuring server safety and maximizing uptime by catching danger hours before a real fire could even start.
We've had a great deep dive into this little sentinel. So before we wrap up, here's a thought for you to consider. This device uses photoelectric detection for smoldering smoke and a thermal sensor for heat. As the components inside our server racks keep getting smaller and hotter, which risk do you think the future of environmental monitoring will have to prioritize even more aggressively? Smoke or thermal runaway? We'll leave that with you.